Hi everyone, this is Geeta. Today we are learning about the concept finest algorithm in machine learning. The contents are: what is finest algorithm in machine learning? How does it work? Limitations of finest algorithm, implementation of finest algorithm, and the use case. Here, first we are learning the what is finest algorithm in machine learning. To understand the finest algorithm, first we need to know the basic concepts that are three: concept learning, general hypothesis, and the third one is specific hypothesis. Now, first we are learning about concept learning. Concept learning. To understand the concept learning with an real life example, for example, most of human learning it is based on past instances or the past experiences. For example, we are able to identify any type of vehicle based on certain set of features like model, how the car model or the vehicle model, etc. that are defined over a large set of features. These special features differentiate the set of cars, trucks, buses, bikes, etc. from the larger set of vehicles. These features that define the set of cars, trucks, etc. These all are known as the concepts. This is known as the concept learning. Similar to this, machines can also learn from the concepts to identify whether an object belongs to a specific category or not, or it can identify a vehicle like types based on the past experience. Any algorithm that supports concept learning requires the following: training data, target concept, and the third one is actual data objects. Now, the second one is the general hypothesis. General hypothesis means the hypothesis in generally is an explanation for something. The general hypothesis is basically states the general relationship between the major variables. For example, a general hypothesis for ordering a food would be I want a burger. Here we will represent the general hypothesis in this format like G equals to open braces question mark and the close open braces. By this way we will represent general hypothesis. Now the third type is specific hypothesis. Here the specific hypothesis it fills all the important details about the variables given in the general hypothesis. The more specific details in the example would be a I want a cheeseburger with a chicken pepper cream with a lot of it. Here, the specific hypothesis we will represent in the form of is equals to open braces. In generic hypothesis, we are representing the question mark. In the specific hypothesis, we are representing with the null. This is the difference between the generic hypothesis and the specific hypothesis. Now, how it works. Here, in the machine learning, first we are initializing the edge. The process starts with initializing the edge with the most specific hypothesis. Generally, it is the first positive example in the dataset. Next, we will check for each positive example. If the example is negative, we will move on to the next example. But if it is a positive example, we will consider it for the next stop. Here, first, the process starts with the initializing the edge with the most specific hypothesis. Then, if it is the first positive example in the data set, we will check for each positive example. If the example is negative, we will move on to the next example. But if it is a positive example, then we will consider it for the next step. We will check if each attribute in the example is equal to the hypothesis value. If the value matches, then no changes are made. If the value does not match to that, then the value is changed to a question mark in the genetic hypothesis. We do this until we reach the last positive example in the dataset. Now, the limitations of Finders algorithm. Here, there are few limitations of the Finders algorithm. These are: there is no way to determine if the hypothesis is consistent throughout the data. If it is inconsistent, training sets can actually mislead the Finders algorithm since it ignores the negative example. Finders algorithm does not provide a backtracking technique to determine the best possible changes that could be done to improve the resulting hypothesis. These are the limitations of Finders algorithm. Now, the implementation of Finders algorithm. This is the example, the concept of this particular problem. We will be on what age does a person like to go on a walk. Here, in this example, looking at the data set, we have here six attributes. Six attributes are time, weather, temperature, company, humidity, wind, ghost. These are the attributes. Here we in this data set we have the six attributes and a final attribute that defines the positive or negative example. In this case, S is a positive example, which means the person will go for a walk. So now the general hypothesis is first H not equals to, we'll write the morning, sunny, like here will be the general hypothesis, we'll write like this. Then now we will consider the each example one by one, but only the positive example we will consider the first. We will check it is match or not. Morning, morning, same, sunny, sunny, same, warm. Your which is different, which is which is negative, we will consider that is a question mark. Then like this, we will replace all the different values in the general hypothesis to get a resultant hypothesis. Now that the how the Finders algorithm works. Here, example with Python. This is in the Finders algorithm. Here we are importing the pandas as PD and the numpy as NP in Python. Now we are reading the one data in the CSV file. The data equals to PD like pandas dot read CSV data CSV. Here we are putting the data CSV file, print data n. Then making an array of all the attributes here. D equals to np numpy dot array data print in the attributes of all the attributes it should be print. Then segregating the target that has positive and negative examples. Here we are training the function to implement the Finders algorithm. If it is a S, and here we are training to implement a Finders algorithm. Here we are defining the train CT for I value in enumerate T. If value equals to S, then specific hypothesis equals to C of I dot copy. If it's not, then it will break. Then it will go to the next. For I, the value in enumerate C. If T of I equals to S, Then for x in range, length of specific hypothesis, if value of x is not equal to specific hypothesis, then the specific hypothesis we will write as question mark. If it is not, then it will come false. Return specific, then it will return the specific hypothesis. At last, we are obtaining the final hypothesis as print n the final hypothesis prime t target. Here we are training the function to implement as find a solve algorithm. At last, we are obtaining final hypothesis. The output we will get is the all the attributes will display the first time weather, temperature, company, humidity, and wind goes. This will get the output. Thank you.